in the cold darkness of the solar system, hundreds of millions of kilometers from Earth, a small world is quietly orbiting Jupiter. Seen from afar, it is only a white-gray sphere. Seen from afar, it is only a white-gray sphere, crossed by reddish-brown cracks like enormous scars. Its surface is so cold that it is almost impossible to imagine. There are no forests, no blue oceans, no thick atmosphere like Earth's, no cities, no sounds, fuck atmosphere like Earth's, no cities, no sounds, no life that human eyes can see. But beneath that ice, scientists suspect that a vast ocean may exist, a hidden ocean may exist, a hidden ocean, a dark ocean buried beneath an ice shell tens of kilometers thick, and, astonishingly, that ocean may contain more water than all the oceans on Earth combined. That world is called Europa, one of Jupiter's largest moons. For many decades, Europa has made scientists ask a big question. If life does not only exist on Earth-like planets, but can hide in underground oceans beneath ice, then could Europa be one of the most promising places to search in the solar system? And to answer that question, NASA has sent one of the boldest planetary exploration missions in history, the Europa Clipper mission. This is not a simple journey. Europa Clipper is not traveling to a gentle planet. It is heading toward Jupiter. Jupiter, the largest planet in the solar system, a giant gaseous world with an extremely powerful magnetic field, violent storms, and a dangerous radiation environment that can damage spacecraft electronics. But around that harsh planet is a small moon that may be hiding an ocean capable of supporting life, and that is why Europa Clipper was created. On October 14th, 2024, Europa Clipper left Earth and began its nearly 6-year journey to Jupiter. The spacecraft does not fly directly to its destination through space. Saving energy is vital. It must use the gravity of planets like a cosmic slingshot, passing by celestial bodies to gain speed and adjust its trajectory. After a journey of billions of kilometers, Europa Clipper is expected to arrive in the Jupiter system in 2030. But the special thing is that this spacecraft will not land on Europa. It will not drill through the ice, and it will not drill through the ice, and it will not drill through the ice, and it will not directly search for alien life. Europa Clipper's mission is more subtle, but also much more important. It will try to answer the question of whether Europa is a place that could be habitable. In other words, Europa Clipper is not searching for aliens. It is searching for evidence of an environment that could support life. To understand why Europa is so special, we need to go back to what humanity has learned about this moon. Europa is one of Jupiter's 4 large moons, observed by Galileo Galilei in 1610, together with Io, Ganymede, and Callisto. To sow wisely, the path ahead is steep. Europa helped change humanity's understanding of the universe. When Galileo saw these moons orbiting Jupiter, it showed that not every celestial body revolved around Earth. It was one of the important pieces of evidence that helped break the old model of the universe and opened the way for modern astronomy. But for many centuries, Europa remained only a small point of light in telescopes. It was not until the age of spacecraft that humans began to see its true face. The Pioneer, Voyager, Galileo spacecraft, and later observation missions showed that Europa is unlike ordinary dead moons. Its surface is very bright, rich in ice, has fewer impact craters than expected, and is cut by countless long cracks. This suggests that Europa's surface may be geologically young. Meaning it has been renewed or altered in the relatively recent past. On a small and frozen world, a young surface is a remarkable sign. It suggests that something may be happening underneath. And the most fascinating hypothesis is that beneath Europa's ice shell lies a global ocean. That ocean does not exist because of sunlight. At Jupiter's distance, sunlight is much weaker than on Earth. If it relied only on heat from the sun, Europa would probably have frozen completely long ago. But Europa has another energy source, tidal forces from Jupiter. Jupiter has enormous mass, tidal forces from Jupiter, and as Europa orbits it, Jupiter's gravity continuously pulls on this moon. In addition, Jupiter's other large moons also exert gravitational effects on Europa, causing its orbit not to be perfectly circular. As a result, Europa stretches, compresses, and deforms very slightly, but continuously, during each orbit. That deformation generates heat inside. This phenomenon is called tidal heating. We can see an even more extreme example on Io, the moon closer to Jupiter than Europa. Io is affected by tidal forces so strongly that it becomes the most volcanically active body in the solar system. Europa is not as extreme as Io. But tidal forces may still be enough to keep the ocean beneath the ice from freezing completely. And this is exactly what makes Europa so special. On Earth, wherever there is liquid water, energy, and suitable chemistry, life can appear in extreme environments that humans once thought impossible. At the bottom of Earth's oceans, near hydrothermal vents, organisms can live without sunlight, relying on chemical energy from deep underground. This opens up a bold possibility. If Europa has a salty ocean, a rocky floor beneath it, chemical exchanges, and an energy source from tidal forces, then it may possess the basic conditions for microbial life. No one claims that Europa has life, but Europa provides enough reasons to make humanity come closer and investigate, and that is the mission of Europa Clipper. When it reaches Jupiter, Europa Clipper will not orbit Europa like a normal satellite. The reason is simple. The environment around Europa is extremely dangerous. Jupiter has a powerful magnetic field that traps and accelerates charged particles, creating intense radiation zones. A spacecraft remaining too close to Europa for a long time could quickly be damaged by radiation. Therefore, NASA chose a smarter strategy. Europa Clipper will orbit Jupiter and repeatedly fly past Europa during close approaches. Each flyby is an opportunity for observation. Then the spacecraft moves farther away again, reducing the time exposed to intense radiation before returning for the next approach. Throughout the mission, Europa Clipper is expected to perform 49 flybys of Europa. Each one is like a slice of data. One time observing this region, another time observing another region. Gradually, the data are combined into a more complete picture of this icy moon, and the spacecraft is equipped with extremely sophisticated scientific senses. It has cameras to capture highly detailed images of Europa's surface, helping scientists study cracks, young ice regions, disturbed surface areas, and structures that may be related to activity beneath. It has ice-penetrating radar designed to send signals through the ice shell and investigate the internal structure. How thick is the ice? Are there pockets of water close to the surface? Are there regions showing exchanges between the hidden ocean and the surface? It has spectrometers to analyze the chemical composition of the surface, searching for traces of salts, organic compounds, or materials that may have been brought upward from the ocean beneath the ice. It has thermal instruments to detect unusual warm regions, which may indicate geological activity or the upward movement of material from the interior. It has a magnetometer to study how Europa interacts with Jupiter's magnetic field. If Europa truly has a salty, electrically conductive ocean beneath its surface, that ocean could generate induced magnetic signals. By measuring those signals, scientists may infer the properties of the hidden ocean. It also has instruments to analyze dust particles and gases, in case Europa has water plumes erupting from the surface. If the spacecraft passes through such a plume, it could sample Europa's material without penetrating the ice. This is what makes Europa Clipper so dramatic, because beneath that ice shell may lie an ocean humanity has never seen. We cannot send a submarine there yet. It is not easy to drill through tens of kilometers of ice on a distant world. But if Europa itself ejects material from below onto the surface or into space, then Europa Clipper may collect clues while flying past. A spacecraft passing through Jupiter's darkness, racing through dangerous radiation, skimming past an icy moon, trying to catch a few particles of dust or molecules that may carry information from an ocean beyond Earth. That is not science fiction. That is part of the reason Europa Clipper was sent. But the big question remains, does Europa have life? The honest answer is that at present we do not know, and Europa Clipper will not be able to directly answer whether living organisms exist there. It does not carry a microscope to search for bacteria. It does not drill into the ocean. It does not take water samples directly from the floor of Europa's sea. It does, but it can answer more fundamental questions. Does Europa really have an ocean? How deep is that ocean? How thick is the ice shell? Does the surface exchange material with the ocean below? Are there organic compounds? Is there a source of chemical energy? Is there a stable environment that has lasted long enough for life to have a chance to appear? These questions are important, because in the science of searching for life, we do not begin by imagining organisms. We begin with conditions. Life as we know it requires liquid water, the necessary chemical elements, a source of energy, and time. If Europa has all of those factors, then it becomes one of the most important places to search for extraterrestrial life in the future. What makes Europa special is that it does not lie within the traditional habitable zone around the sun. When we think about places where life could exist, we often think of an Earth-like planet with an atmosphere, oceans on the surface, and enough sunlight. But Europa suggests another possibility. Life may exist in oceans hidden beneath ice, far from the sun, thanks to internal energy and the gravity of a giant planet. If that is true, the implications would be enormous, because Europa is not the only ocean world. Ganymede, Callisto, Saturn's Enceladus, Titan. Even some other distant bodies may contain underground oceans. If oceans beneath ice can support life, then the solar system may have many more potential habitats than we once thought. Then the question is no longer only whether there is life on Europa, but whether life in the universe could be far more common. Europa Clipper is not alone in this age of exploration. The European Space Agency has also launched the JUICE mission to study Jupiter and its icy moons, especially Ganymede. Together, these missions open a new era, an era in which humanity focuses on ocean worlds in the solar system. But Europa still has a unique attraction. Its surface resembles a map torn apart. Long streaks run across this small world as though the ice shell had been stretched, broken, and frozen again. There are chaotic regions where blocks of ice appear shattered, drifted, and then reassembled. Some scientists believe these structures may be signs of material from below, rising close to the surface. If that is true, Europa's surface is not just a dead shell. It may preserve clues from the ocean beneath. Every crack may be a question. Every discolored ice region may be a chemical trace. Every unusual heat signal may suggest a process occurring below. And every time Europa Clipper flies past, the spacecraft will try to read those traces. Imagine in 2030 when Europa Clipper first enters the Jupiter system. Before it lies a giant world, Jupiter, with swirling cloud bands, storms larger than Earth, a powerful magnetic field, and moons moving around it, like a miniature planetary system. In that environment, Europa Clipper must operate with precision, down to the second. It must point its instruments at Europa during the brief moments of each flyby. It must collect data, store it, transmit it back to Earth, and prepare for the next approach. Signals from Jupiter to Earth do not arrive instantly. The distance is so great that every piece of data sent back is itself a journey through space. Images, measurements, and signals from Europa will take time to reach the antennas on Earth, and when they arrive, scientists will begin putting the pieces together. One image may reveal a young ice region. A radar measurement may reveal structures beneath the shell. A magnetic signal may strengthen evidence for a salty ocean. Spectral data may detect important compounds. A signal from dust or gas may suggest that material from the interior has reached space. All of those pieces together will answer one question. Could Europa be a habitable place? No one knows the answer in advance, and that is exactly what makes this mission fascinating. Science does not always seek certainty. Sometimes science begins with a question large enough that humanity is willing to send a spacecraft billions of kilometers into the dangerous environment around a giant planet. Europa Clipper is a symbol of that curiosity. It represents a bold idea that life may not belong only to Earth, that out there beneath the ice of a distant moon, there may exist the conditions biology needs to begin. That, in the darkness, where sunlight barely reaches, an ocean may still be quietly moving. Perhaps Europa is only a lifeless ocean world. Perhaps beneath the ice there is only water. Salt, rock, and chemistry that never cross the boundary into life. But perhaps somewhere in Europa's dark ocean, near the seafloor, near sources of chemical energy, complex reactions have occurred or are still occurring in ways humanity has never witnessed. Europa Clipper does not promise to find life. Europa Clipper does not promise to find life, but it may tell us whether Europa deserves to be the destination of an even bolder mission. A lander, an ice-penetrating drill, or an ocean-exploring robot in the distant future. And if one day humanity truly obtains a sample of water from Europa's ocean, then Europa Clipper may be regarded as the important first step on that path. In the history of space exploration, there are missions that do not only answer the questions of the present, but also open questions for future generations. Europa Clipper is such a mission. It does not merely study an icy moon. It tests a major hypothesis about life in the universe. It challenges the old idea that a habitable place must resemble Earth. It forces us to think more broadly, that a cold, dark world buried beneath ice may still be a place worthy of hope. If Europa has the conditions necessary for life, that does not prove life exists there, but it would prove that nature can create habitable environments in places stranger than we imagined. And if an ocean beneath ice around Jupiter could be habitable, then how many similar ocean worlds might exist in this galaxy? That is the question that makes Europa Clipper larger than a spacecraft. It is a search for possibility, the possibility that Earth is not the only place with conditions suitable for life. The possibility that beneath silent layers of ice, alien oceans may exist. The possibility that life, given enough water, energy, and chemistry, may find a way to emerge in places that seem impossible. In the coming years, Europa Clipper will continue its long journey to Jupiter. It will travel through the coldness of space, farther from the sun, toward a giant world, dominating the outer solar system. And when it arrives, it will repeatedly fly past Europa, the icy moon with the mysterious ocean beneath. Each flyby will be a brief moment. Each flyby will be a brief moment, but from those moments humanity may gain answers that change the way we view the universe. Perhaps Europa is only a dead world. Perhaps Europa is only a dead world. But perhaps it is a sign that life does not need a blue sky like Earth's to have a chance. That is why Europa is important. Because in the search for extraterrestrial life, sometimes the greatest clue is not found on an Earth-like planet, but in the darkness beneath the ice of a distant moon orbiting Jupiter. Europa Clipper is flying there, not to confirm miracles, but to ask the universe a profound question. On Europa, beneath that frozen ice, is there an ocean waiting to be explored? And could that place once have had or still have conditions suitable for life? If you find this topic interesting, please support the channel by liking the video, subscribing to the channel, and turning on notifications so you do not miss future journeys about Jupiter, Europa, ocean worlds, and the greatest mysteries of the solar system. Your support will help the channel continue creating scientific videos that are fascinating, easy to understand, and more authentic. Thank you for watching, and see you again on future journeys through the vast universe.
Cảm ơn bạn đã theo dõi và hẹn gặp lại trong những chuyến du hành tiếp theo giữa vũ trụ bao la.